In this video, we're going to find out how to find exact trig ratios. So for example, sine of 3 pi by 4, what is the exact trig ratio that corresponds to that? If you realize, you might realize that 3 pi by 4 is 3/4 of pi. And if pi, just up here on the top, if pi is right here, pi by 2 is right here, this is 0, 3/4 of pi is this line here. So if we were to do this in degrees, it'd be 135 degrees. So essentially, we're just asking what sine of 135 degrees is. In grade 11, you learned how to do this either with the unit circle or special triangles, and that's basically what we're going to do here. You just got to get used to the radian measure. So just as a quick review, your unit circle, here we go. We want to know what the sine, cosine, and tangent values of any of these significant points around the circle are. So let's first off, let's label these points with their corresponding angles. So we know, of course, that this is pi. We know that this is 0 or 2 pi, right? A full revolution would be 2 pi. We know that this is pi by 2, 90 degrees is half of pi. And down here is 3 pi by 2, 3/2 of pi, right? So then we can go to our quarters of pi, right? We have 1/4 of pi, 2/4 of pi. So this is pi by 4. 2/4 of pi is just the same as 1/2, so we don't need to worry about that. 3/4 of pi, or 3 pi by 4, is right there. And then we can keep going. So that's 3/4. Pi would be 4/4. And then we can keep going. 5/4 of pi. And we can keep going. 6/4 would be down here. And then lastly, 7/4 of pi. 7 pi by 4. There we go. So there's our quarters taken care of. And lastly, we have our sixths, right? So we have our, actually, let's do thirds first. So pi we can divide in 3, 60 degrees, 120 degrees, and then pi. So instead of using degrees, though, we're going to call this pi by 3. We're going to call this 2 pi by 3. And then we have pi, and then continuing on, so that's 1/3, 2/3, 3/3. So then here we would have 4/3. So 4 pi by 3. And then lastly over here we'd have 5/3, or 5 pi by 3, right? And then now we can do our sixths. So we have here our 30 degrees is like saying a sixth of pi, pi by 6. 2 pi by 6 would be here, which we've already taken care of. 3 pi by 6, 4 pi by 6, 5 pi by 6. So 5/6 of pi. Right? And we keep going. 6/6, 7/6, 8/6, which we've already included. 9, 10, 11/6 of pi. Right? And there we go. Those are all sort of our major values we got to know the sine, cosine, and tangent ratios for. Now, one thing to keep in mind, remember, each point on this unit circle, if we say this unit circle has a radius of 1, right? That's why it's called the unit circle, right? Each of these points along the circle has a coordinate, an x and a y coordinate. So if we're looking at this one, for example, we have our x coordinate and our y coordinate. And if you remember, this is our angle here. So let's just call this our generic angle theta. This angle here, if you think about it, we know our radius is 1, right? This is always 1. And if you do the math, that means our adjacent side here is always going to equal the cosine of theta. And this side here, because the opposite side, is always going to equal the sine of theta. So if we're looking at the coordinate of this point up here, the coordinate of any point on this unit circle is always going to be cos theta is the x coordinate, and sine theta is the y coordinate. If tan's not included there, so to include tan, we know tan, one of the identities for tan, is that it's just equal to sine over cosine. So we can use this as a bit of a key to find any of these critical values around the circle. And we do that with our special triangles. There's basically 2 special triangles that we care about here. one of them being the 45, 45, 90 triangle. And this triangle, we can see this triangle in the example we just did, any of the pi by 4s or any of the multiples of it, right? We would have that triangle where this side and this side are the same length because this angle is essentially 45 degrees, or pi by 4, as we call it in radians. So if you know this, and if we call this length 1 in this triangle, we know because it's, because these lengths are the same, it's a 45, 45, 90 triangle, this side also has to be 1. And if we use Pythagorean theorem, you can find that this length is root 2, right? So if we're looking for the sine of theta, actually let's just call theta this one. We'll call this angle here theta. If we're looking for the sine of theta, it's just the opposite over the hypotenuse, so 1 over root 2, right? And if we're looking for the cosine of theta, same thing. It's the adjacent over hypotenuse, which is just 1 over root 2. So those are our special values for anything involving any multiple of 45 degrees. Or we're not going to call it 45 degrees anymore. We're going to call it pi by 4. I'm actually just going to replace that here, pi by 4. Okay? So on our unit circle, let's actually replace that. So this one here, pi by 4, the x and the y coordinate of that. Well, as we just said, the cosine of that angle is going to be 1 over root 2. And the sine value is also going to be 1 over root 2. We know they should be the same length because it's an isosceles triangle. So that's our first one. Going over here to our next sort of multiple of that, 3 pi by 4. Well, we know that these lengths are going to be the same here, this length and this length, because they're similar triangles, or they're the same triangles, just flipped around or mirrored around. So the point that corresponds to this is just going to be 1 over root 2, 1 over root 2. But remember, if we're thinking of this point as a coordinate, the x part of that coordinate is going to be negative. So negative 1 over root 2 and 1 over root 2. There you go. So that's that 3 pi by 4. And we can continue. So the one down here, 5 pi by 4. Now we have the x and the y coordinate being negative 1 over root 2 and 1 over root 2, or negative 1 over root 2 and negative 1 over root 2. That makes sense. And lastly, 7 pi by 4. The x part of that coordinate is going to be positive because it goes in the x direction positive, and then the y part's going to be negative. So 1 over root 2, negative 1 over root 2. You can also figure these out, the negatives and positives, from your cast rule, right? These follow the same rules as the cast rule. So here, both sine and cosine are positive. Here, just the cosine is negative. Here, both are negative. And here, just the sine is negative. What we didn't do, actually, is we didn't do the points sort of that correspond to these main points. Right here, right here, right here, and right here. But those are pretty straightforward. What's the coordinate of 0 degrees, or 2 pi degrees? Sorry, I should say radians, not degrees. Well, the coordinate of that is just going to be 1, 0, right? Because the radius is just 1. Pi by 2 has a coordinate of 0, 1. Pi has a coordinate of negative 1, 0. And 3 pi by 2 has a coordinate of 0, negative 1. There we go. So now we've taken care of sort of 8 of these big angles here. And we can now look at our next special case. These are all the multiples of pi by 6. So when we have this pi by 6, we used to call that 30 degrees, right? So the way we can do that is actually by looking at a equilateral triangle and breaking it down into 2. Because if we do that, we know this angle here is 90. And this angle here, we know in an in an equilateral triangle, each of the sides is 60 degrees, right? That means that angle has to be 60 degrees. And if we just use 180 minus 60 minus 90, we know this one must be 30 degrees, right? Now, in radians, we would call this pi by 3, or a third of pi. And in radians, we would call this pi by 6, right? Those are the equivalents in radians. So we can just use a little bit of trigonometry to figure out what those lengths are. Also note that I'm just going to erase those for now just to make it clear. We'll just deal with degrees here just to make everything a little bit clearer. If this length is 2, then this length is also 2. And I do that for a reason, and that's so that this is 1 down here. So basically we're just looking at this triangle here on the left. So if we're looking at 60 as our theta, right? So if we want to do sine of 60, in this case, it's going to be, oh, well, we need to find what the height of this triangle is, right? And if you use Pythagorean theorem, I'm not going to spend time doing that. You can try that yourself. This height is just root 3, right? It's just 1 squared plus 2 squared, or sorry, 2 squared minus 1 squared, and then take the square root of that. So it's root 3. So if we're finding the sine of 60 degrees, sine is just opposite over hypotenuse. So that's just root 3 over 2. And if we want the cos of 60 degrees, that's going to be adjacent over hypotenuse, which is just 1 over 2. And we can do the same thing for sine, or sorry, for the 30 degrees, right? So if we do sine of 30 degrees, we're going to do the opposite of 30, which is 1. And the hypotenuse is 2. And if we do cos of 30 degrees, it's going to be root 3 over 2. Root 3 over 2. There we go. Now, of course, we're dealing with radians, so you can easily convert these. These actually are, we know this is pi by 3, and we know this is pi by 6, right? So when we go back up to our unit circle, we can sort of fill in the rest of these values. So let's do the first quadrant together, and I'm going to let you do the rest of them yourself. So for the first quadrant, pi by 6, we already said pi by 6 is the same as 30 degrees. So the cosine is root 3 over 2. And the sine is 1/2, and those will be positive. If we do pi by 3, so 60 degrees, if you go down to the bottom again, it's just going to be the opposite. So 1/2 root 3 over 2. Now, I'm going to pause the video, or you're going to pause the video here. See if you can fill out the rest of those missing values. When you're done, unpause to check your work. There we go. There's the rest of the values in the circle. So just double check that you've got them in the right places. Now that we've done that, we've sort of refreshed our memory on our unit circle, let's apply some of these things to find some exact trig ratios. So for example, our first question here on the right is sine 3 pi by 4. Well, 3 pi by 4 we know is 3/4 of pi. So it's in this region here, we already talked about this, is this one over here. And remember, sine refers to the y part of the coordinate. The y part of the coordinate, we can just look it up from this table, is 1 over root 2. So that's the answer, 1 over root 2. That's it. Now, the thing is, you're not going to get this completed table or the completed circle on tests or quizzes. You got to be able to either create it yourself or visualize it in your head. We'll help you out with some strategies to be able to do that a little bit better. So let's go on to the next question. Secant of 7 pi by 6. Well, secant isn't very nice. We don't see secant anywhere on our unit circle, right? What we do see is sine and cosine. So let's change secant into sine or cosine. What is secant? Well, we know secant, sort of an identity. Off to the side, we'll do this. Secant of theta is just 1 over cosine of theta, right? So we can rewrite this as 1 over cosine of 7 pi by 6, right? So basically, if we can find out what cos of 7 pi by 6 is, then we're golden, right? We're good. So again, referring back to our unit circle, 7 pi by 6. So we know that's just past 180 degrees, right? Because 6 pi by 6 would be half, would be pi. So 7 pi by 6 is the next one over here. And if we're looking for the cosine value, we're looking for the x value, which is negative root 3 over 2, right? It's right. It's right over here. So the answer to this is 1 over negative root 3 over 2. Okay, that doesn't look very nice. So let's simplify that a little bit. When we're dividing by a fraction, remember, it's same as multiplying by the reciprocal. So essentially, it's saying 1 times 2 over negative root 3. And that's the answer. Out of convention, usually we like to change the negative sign to the numerator. And we also like to rationalize the denominator, but I'm not going to worry about that for these questions. So negative 2 over root 3 is an acceptable answer. Next question. Cotangent of 2 pi by 3. Again, remember, what is cotangent? Well, it's related to tangent, right? And what is tangent? Tangent is sine over cos. Cotangent then is equal to the reciprocal of that, right? Which is cos over sine. So essentially in this question, what we're looking for is we're looking for cos of negative 2 pi by 3 over sine of negative 2 pi by 3. The next question is, what is negative 2 pi by 3, right? Think of this as negative 2/3 pi. What does that even mean? Well, we know pi is here, right? And we know negative means we're going around this way. So if we're going around negative 2/3 of the way, 1/3 would be right here. 2/3 would be here. So that is basically the point we're looking at. We're looking at this 4 pi by 3. If that's the positive angle that corresponds to that, right? So if we look at that, we were looking for, going back over here, we're looking for the cos over the sine of that value. So the cos is negative 1/2. So let's do that over here. So that is negative 1/2 over the sine of that value, which is negative root 3 over 2. Now, again, if we simplify this, we can flip the reciprocal. Sorry, we take the reciprocal of the denominator when we flip and multiply. So it's going to be negative 1/2 times negative 2 over root 3, basically. And let's just simplify that to make it nice. So those negatives are going to cancel out. Those 2's are going to cancel out. We basically end up with 1 over root 3. That's a little bit nicer for our final answer. I want you to try these next two examples yourself. Pause the video here, try them yourself. When you unpause, the answers are going to pop up, so make sure you've actually tried them before unpausing. Okay, so here they are. Now, I didn't show all my in-between steps because I want you to do that part. I didn't show you how I got that secant pi by 4 was equal to root 2. I want you to try that yourself. Remember, secant is 1 over cos, so basically find cos of pi by 4 and then simplify it. That actually comes out to root 2. Same thing with cos 2 pi by 3, that's negative 1/2. Tan pi by 6 simplifies to 1 over root 3. And cosecant 3 pi by 4 simplifies to root 2. If you do all the simplification there, you notice the root 2's cancel out, you end up with negative root 3 over 2. Same thing if you go to the second question. I'm not going to show you all the simplification. You can try it yourself. But sine of 5 pi by 4 is negative 1/2. Cos of 11 pi by 6 is root 3 over 2. Cotangent, remember, cos over sine, of pi by 3 is 1 over root 3. It simplifies to 1 over root 3. So then basically your answer simplifies to this. I just turned it into one fraction at the end to maybe make it a little bit nicer. Negative 2 minus root 2 over 2 root 2. A lot of 2's there. All right, there you go.